Good morning, everybody, and welcome back to Grade 9 Science in the Optics Unit. We are nearing the conclusion of our Optics Unit as we head towards the end of the month. We will be writing our online in-class summative assignment on Monday, April 27th. Thursday, prior to that, we will have our review session on Zoom. You will be given the summative assignment, and then we will review all of the concepts in class, and then you'll have Monday to work through that assignment. Important to note, this assignment is entirely independent, okay? No collaboration permitted, okay? I'm leaving this up to you guys and trusting you guys to work on it independently. Please don't violate my trust on that, okay? So, taking a look at today's date on the planner, we are going to talk a little bit about the senses gizmo in prefacing the corrective lenses. We are in a optics physics unit here, okay? So we're talking about the physics behind the electromagnetic waves of light, right? And the wave-like properties of light and those electromagnetic spectra that we discussed at the beginning of the year. The way that our eyes view things is important for us to understand in order to understand why we use corrective lenses the way that we do. So this activity today is going to look a little bit into the human anatomy and the biology of the physics behind vision and sound. So we've talked about light waves, and we've talked about sound waves in our physics unit thus far. Today we're going to dip into the biology just a little bit, just to graze the surface and give us some background knowledge so that we can really, truly piece together the human anatomy and biology of vision and sound and piece that together with our physics knowledge. So what I would like for you guys to do at this time is go to Edsby, go to your daybook, and download, under today's date, the Gizmo Senses, please. And once you've downloaded that OneNote, please let me know by just raising your hand or giving me a thumbs up in the chat. Perfect.
It's Gizmo Senses, correct? Okay, I got it.
Perfect. Anybody need more time still? Ethan, Sully, you got it? You got it downloaded? Perfect. Andrew, you got it downloaded? Karar, you got it downloaded?
Yeah.
Seamus? Oliver, you're good? Connor, you good? Oliver, you're good?
Yeah.
I'm good.
Okay. Roy, you're good. Daniel, you're good. Oscar says he's all good. He's got the thumbs up. Charlie, you good? Alejandro, you good? Mr. Ganem? John says he's good. Domingo says he's good. Carter's all good. Tyson, you good, bud? Tyson, Alejandro? Tyson, Alejandro going once. Tyson, Alejandro going twice. Okay. All right, guys, so we're going to move forward here. So your downloaded worksheet should look like this, student exploration senses. You'll notice at the top, as always with gizmos, we have a list of vocabulary that we need to work through. So let's take a look at.
Oh, sir, I have it. Sorry, I couldn't find my Zoom page. I had two desktops.
All good, buddy. All good. All good, Tice. For those of you that are wondering, if you can't find your Zoom page or you don't want to, you can just press the space bar, and then that will unmute you temporarily. Okay, a couple things we need to define here. The auditory cortex is a part of our brain, okay? This is the part of the brain that, based off the word auditory, you might have derived, is responsible for processing auditory signals, or in other words, sound from the ear. So the ear is the organ associated with the sense of sound, and we knew that. But what is happening in the ear? Well, there's an auditory nerve, and a nerve that carries the sound signals from the cochlea in the ear to the brain, okay? So the sound waves come into our ear, okay? They hit the cochlea, and then they go through the auditory nerve into a part of our brain called the auditory cortex. The auditory cortex is responsible for processing the sounds and registering them in our minds. The auditory cortex is located in the temporal lobe of the cerebral cortex, which is on the outside of the brain, just above the ears, okay? The cerebrum is the wrinkly area that forms most of the outer part of the brain. It is responsible for the integration of complex neural signals and the initiation and coordination of voluntary activity in the body. Voluntary activity, things like walking, jumping, clapping your hands, and doing such simultaneously. Involuntary is breathing, blood flow, organs, squeezing food through the digestive tract, respiratory system, all of that stuff. Your heart beating, right? That's an involuntary activity. It was voluntary and we got distracted playing Fortnite. I know sometimes you think your heart might stop beating when you're in the final two and you've got a guy building up on top of you. But I'm telling you, your heart's still beating because that's an involuntary act, which is not controlled by the cerebrum. Okay, that's also where the term cerebral comes from, by the way. If you've been told that you're a cerebral person, usually that means that you're well thought out. That means that your voluntary actions are well thought out and processed well. Cones. Cones are very important to us in this unit because we're going to talk about rods and cones and their role in the visual process. So the process of vision. Cones, these are photoreceptors. Photoreceptors meaning they receive the photons, the light, right? So photoreceptors, a light-sensing cell embedded in the retina at the back of the eye in vertebrates. Guess what? We are vertebrates. Dogs are vertebrates, cats are vertebrates. All the animals that we know and love that are mammals are typically our vertebrates, anything with a spine, okay? And eyes is a vertebrate. So the cones are basically located in the back of our eyes at the retina, and the cones are responsible for color vision. And as such, we know, based off of the color wheel and the electromagnetic spectra, that there are three primary colors: red, green, and blue. Well, guess what? There's a separate cone for each of those colors. There are cones for red light, green light, and blue light. Cones work best in bright light. Continuing our conversation about the visual cortex and the optic nerve. So rods, very much like cones, are also photoreceptors, but these ones are not for color. These ones are just for picking up, sensitivity of light. So rod cells are more sensitive to dim light than cone cells, but they cannot distinguish between different colors. That's why we use a combination of rods and cones for our vision. Now, how does the signal get transmitted? Well, through the optic nerve. So when we talked about the ear, we talked about the auditory cortex and the auditory nerve. Well, it's the same thing for our vision. We have an optic nerve, which is a nerve that lies behind the eye and transmits signals from the retina to the brain, okay? That's a neural pathway. So the neural pathway, a series of connected nerves or neurons along which an electrical impulse travels through the body. An electrical impulse travels through the body. Think about this. We talked about fiber optics last class. Think about this as our own version of fiber optics, okay? In our bodies, we've got these neurons, these neural pathways. And that's kind of like our fiber optic system, transferring information from our rods and cones or from our cochlea in the ear through our auditory nerve to the auditory cortex, or from our rods and cones through the optic nerve into our visual cortex. The visual cortex, much like the auditory cortex, is a part of the brain that receives and processes visual light signals from the eye. It's located in the occipital lobe of the cerebral cortex, which is on the back of the brain. So back here, okay? So let's go over to our gizmo now and see what we can apply from those definitions. So the prior knowledge questions we're going to go through together as a class, so if everybody can unmute themselves, that'd be great. What are different types of information that your body can detect from the outside world? What do we think? What are some different types?
Taste.
What? Sorry, Corn?
Wait, am I lagging?
No, you're good. I just didn't hear what you said.
Oh, like the other senses? Like smelling?
Yeah, name a couple. Smelling is one for sure.
Feeling?
Feeling is one for sure.
Tasting?
Yeah.
Hearing?
Hearing
Yeah.
for sure. So we've got smell, feel, taste here. What's the one that we're missing? What's this unit
Sight.
about?
NC.
Yeah,
Sight.
sight, right? Okay, perfect. So what I want you guys to do is I want you to write down 3 senses there, just 3 of them.
Oh. What if you wrote more?
Well, I want you to write 2 more. So what are some different types of information that your body can detect in the outside world? Just write down 3. Now I want you to think about which organs are responsible for collecting the information. So if I wrote down taste, which organ am I going to write down?
Mouth.
The nervous
Yeah, your
system?
tongue, right? If I wrote down sight, which organ am I going to write down?
Ooh.
Eyes.
Perfect. Okay, so 3 senses and 3 associated organs. Give you guys a minute to do that.
Oh, I'm so sorry.
So, Mr. Gay.
Yeah.
So, like, if we say feeling, so do we write down like nervous system?
Sorry, if we do what?
Feeling.
Feeling. Yeah, touch, you mean?
Yeah, yeah. I mean,
Sense
I
of
forgot
touch?
what it's called.
Yeah, you could write down skin or hand or.
Nervous
Okay.
system. What about the nervous system? Isn't that
Well, the
like
nervous system
necessarily-
is all of these combined, right? So the nervous system is a combination of all 5 of our senses.
Thank you, Mr. Gay.
Yep. Okay, so going back to sharing my screen now, let's go to the gizmo warm-up. So the gizmo warm-up, again, these gizmo warm-ups are designed to help us get accustomed to the gizmo that we're going to be doing. In this case, it's going to help us walk through the senses gizmo and show us how to control everything. So this gizmo warm-up says that stimuli are changes inside or outside the body that cause a human response. In the senses gizmo, you will explore how different sense organs detect stimuli from the environment and send messages about that stimulus to the brain. On the neural pathways tab, it tells us to click the apple slice and drag it into the white stimulus box, and then drag the eye into the sense organ box. It tells us to click play and then record our observations. So let's go ahead and do that here. So how do I do this? On my computer, I type in EXP. For some of you, as soon as you do that, explorelearning.com will pop up. If not, you need to take the whole thing, explorelearning.com, press enter. It may ask you to log in. If you're already logged in, that's great. Just go to today's class and click on the senses gizmo. Okay, you're going to click on launch gizmo. And once you've done that, it asks you to select the apple. So drag the apple into the stimulus section and drag the eye into the sense section. It asks us to then click play and observe what's happening. What I want you to pay attention to is what happens in this box, and then along the neural pathway, the optic nerve in this case, and then which part of the brain that the optic signal goes to. So the visual signal, where does that light signal get sent to? The electrical impulse. Make some early guesses. Is it going to go to the front? Is it going to go behind the ear? Is it going to go near where the eyes are? Is it going to go on the top? Is it going to go in the back?
Top.
Okay, make some
Sorry,
guesses.
which Gizmos game thing is this?
Senses.
Oh, senses.
Okay, so we click play.
I'm
The
so smart
eye
here.
detects the visual stimulus. It goes through the neural pathway and into the visual cortex at the back of the brain. If I want to see it again, I just click replay. Play, the impulse goes along the neural pathway, the optic nerve there, all the way to the visual cortex. So, what's happening when this is going on? Light receptors, and again, we call these photoreceptors rods and cones. Rods are sensible for are responsible for being the sensitive light detectors. They work better in dim light, and cones are the ones that help us see colors. They work better in bright light. So which is why in a dark room, you can't really see color because 1, there's not a lot of white light bouncing around the room when it's dark. And 2, our cones aren't necessarily activated. They're not necessarily perceiving the images. It's mostly the rods because they're better in dim light situations. So That's why when we're in a dark room, you don't see the bright colors. So those rods and cones are located at the back of the eye, attached to the retina, and they're activated by the incoming light reflecting off of the apple. So we have incident rays coming from a light source. They're being reflected off of the apple and into our eye. Okay, those lights, those light waves, those photons are being received by photoreceptors, rods and cones at the back of the eye, and those photons are sending an electrical impulse through the nerve cells in the optic nerve. When they go through the nerve cells in the optic nerve, they are transferring that light signal to the brain, where it arrives at the visual cortex in the brain, which is responsible for processing those signals and creating a perceptual image in the form of now we're seeing things. It's our vision. The perception of vision occurs in the visual cortex. So yes, our eyes receive the light and the image, but our brain is responsible for creating the image that we view. Pretty cool stuff.
So the place that like creates the image is at the back of our brain?
Yeah, the visual cortex, which is pretty cool because it's pretty far away from your eyes, isn't it? So eyes in the back of your head, gentlemen, not necessarily untrue. Okay, so what do you observe? What I want you to do is I want you to look at these explanations here. So what do you observe? Some keywords I want you to focus on. Light receptors, rods and cones, okay? They receive the light and they're activated by incoming light. Then they pass the rods and cones in the retina, pass an electrical impulse through the nervous system. I want you to call this the optic nerve. So you observe the optic nerve, the electric impulse traveling through the optic nerve and heading towards the visual cortex. So words to highlight. Rods and cones, I want you to use that in your description of what's happening. I want you to use the word optic nerve and neural pathway. I want you to use the word visual cortex to create perception of vision. Okay? Light receptors, rods and cones, optic nerve, neural pathway, visual cortex. Those are the words I'm looking for in that first question. How do you know that the eye senses the apple? Well, we saw the electric impulse going through the optic nerve. We saw that impulse getting sent to the visual cortex. So that's how we know. Third and final question for the warm-up asks us, the neural pathway represents the nerves that connect the sense to the organ, or sorry, the sense organ to the brain. What happens along the neural pathway when the eye sees the apple? Well, an electric impulse is sent. Okay? Okay, so that's the warm-up. Now, I'm going to walk you through some of these questions and tell you what you need to do, and then I'll leave you guys off on your own to work through it. Today, we're doing activity A. So you're going to start on page number 2. Ideally, page number 1 is already done. If it's not, you need to go back and do that. But activity A starts on page 2. You are going to complete page 2 and 3, activity A only. Once you hit activity B, I want you to stop. That's for next class, okay? Activity A focuses on all of the senses and the neural pathways between the organs and the cortex in the brain associated with that organ. So it starts out with the tongue, and then it asks you to reset for the ear. It asks you to play around with different stimuli, and then eventually it asks you to go through each organ and label the location in the brain that those stimuli are processed in. Okay, after that it asks you a little bit about the spinal cord. And finally, the last question of the day, which part of the brain processes hot and cold, and some questions about the hypothalamus. Okay, that question 6 is your last question of the day. So that's all there is for today's class, gentlemen. Thank you for paying attention. Have fun with the gizmo. Do we have any questions?